Good morning. Please do your warm-up now. You have 1 to 4, you have only 2-3 minutes to finish the warm-up. And please take note that the warm-up questions 1, 2, and 3 are all related to our past discussion. And number 4 is actually connected to our new lesson for today. So we have about 2 to 3 minutes to do your warm-up. Okay? Let's try to recall. Okay, number 1, compare and contrast acid and base. What can you say about? Tanisha? Alright, very good. Do you use Venn diagram to produce a connection between acid and the base? And what have you found out? Alright, Tanisha, they're both using what? Okay, they're both using litmus paper to know if the solution is an acid or a base. What about number 2? Antonio, what is the chemical formula for HCl? Chemical name, I should say. Alright, hydrochloric acid. What about number 3, Xavier? Write the chemical name or chemical formula for nitric acid. Xavier, what do you say? HNO3. That's very good. That's awesome. What about number 4? Alright, understand that number 4 is actually connected with our lesson for today. That is actually a chemical equation. What is a chemical equation? What have you learned about in reading chemical equation? Tanisha? Very good. Chemical equation is one composed of a what? Reactants. We have a given reactant. In order to have a chemical reaction, we have the reactants. What else, Tanisha? Okay, it has to be what? A products or products. A chemical reaction or a chemical equation have to have or has to have reactants and products. And what is the main goal for a chemical reaction? It has to be what? It has to be balanced. So therefore, the main goal for a chemical reaction or equation should be balanced. Let's try to take note of the 3 words. Reactions, products, and balance. What are actually the relationship among the 3? When we are talking of chemical reactions or equations, it means that there should be reactants and a product or products. And in a chemical reaction, the reactants and the product should be balanced. That's the main goal. We are talking of the reactants here and basically a product. So the certain number of reactants is equal to the number of the products. Now let's try to understand and analyze what is the meaning of reactants and the products. What is the role? So let's try to understand. We stated a while ago that we have chemical equation and the 3 main factors, 3 main words are reactants, products, and a balance. In a chemical equation, it composes of, let's create a concept map, 5 types. The first type is what we call the combination reaction. When we are talking of combination reaction, it is similar as synthesis reaction. This is the first type. The second type is what we call the decomposition reaction. I call it DR. Okay, or decomposition reaction. And then the third type would be equal to the synthesis or single replacement, the SR. And the fourth type is actually what we call the DR. And the last one is what we call the combination reaction, CR. Let's try to talk about the combination and synthesis reaction. Take note of this sentence for today. We have to write chemical equation. We have to differentiate reactants and the product, and we have to balance the combination reactions. Now, I have included this in the middle of the discussion, so you'll be aware of what is expected from you. Okay? Let's try to talk about combination. From the word combination, how do you say that that is a combination reaction? Paul. Okay, combination reaction from the word to say reactant. So there should be a reactant and a product. Very good. What else? From the word combine, it just easily what? Combine them in order to produce a certain product. That's correct, Alicia. Now, let's try to represent combination reaction with a given illustration. Try to look at that. When we are talking of synthesis or combination reaction, it means this is a combination of A plus B. What is the A? A is merely the reactant. And B is a reactant. There are 2 reactants that produce a compound. So basically, it actually applies the rule that we have to know the reactants and the products. Upon knowing the rule, what do we need to do? The main goal is to balance the reaction. How do we balance the reaction? Let's try to understand. A plus B. Example, we have Na plus F. We all know that an element Na is actually what? Positive 1 oxidation number. And this is a solid. This is just actually an indication the state of a given element or substance. So for now, let's try to ignore it. Combined with a fluorine oxidation number -1. We all know that the oxidation numbers can be found in your table of elements. Okay? Everybody has a table of elements. So let's try to recall. Oxidation number of sodium, +1, and fluorine is -1. And what is 2 there? We put 2 there because according to our past discussion, wall of knowledge, that is diatomic element. If that is diatomic element, we have to put a subscript 2 here. Alright? Let's try to rewrite so you will be able to understand it very well. I'm going to erase the oxidation number because it's been written. It will produce these are the reactants. We're just going to combine them so it produces a product of NaF. You understand? Oxidation number is +1 and -1. Let's try to recall what happened to the oxidation number if they are what? The same? We cancel or crisscross? Addition? Cancel. So very good. So we need to cancel this out. If we cancel, so therefore we can now erase them because we cancel them. So the correct product is NaF. You understand? We are having reactants and products. Now let's try to balance the equation. The main goal is actually balance the reaction. To balance the reaction, we have to count how many sodium atoms we have in a product. Let's try to count. We have sodium, we have 1 here. Fluorine, we got 2 here. In the product, let's try to count how many sodium do we have here. Fluorine 1. There is something wrong with the fluorine. This is 2 and this is 1. The reaction is not balanced. Let's try to recall. In your algebra, we have 2x. This is what we call the literal coefficient, and the 2 is the numerical coefficient in your algebra. Okay, where do you put the numerical coefficient? Is it before or after? Yes, Paul? Yes, very good. Likewise, in chemistry, we put numerical coefficient before the element. Since we have 2 here, we don't have any choice but to put 2 before a compound. If we put 2, we can distribute this. 2 times 1 sodium, 2. 2 times 1 fluorine, we got 2. We notice that the fluorine is already balanced, but take note, along the line, there is something wrong with the sodium and A. This is already 2. What about this 1? 1. So what do we need to put to do? We need to put what? We need to put 2 coefficients. So 2 times 1, we got 2. You will notice that we got 2 and 2. Reactants, and then for the products, 2 and 2. Is the equation already balanced? Very good, it's balanced. Do you have any question? Thumbs up, thumbs down. Alright, some of you are thumbs up, some of you are like that, some of you are down. Any question? Yes, the question? Okay, that's a very good question. Do we need to cross over this? Like what we did in the compound? The answer is no. Because take note, there is a plus sign. Layman's terms before, what we did? There is no trespassing if there is a plus sign. There is no plus sign, so we can trespass. This one, there is a plus sign, so we cannot cross over. There is no trespassing, so we can't do that. You understand? Any questions so far? Alright, let's go on. Let's try to understand more. Example number 2. Hydrogen gas reacts with oxygen gas. Let's try to represent this with a proper equation. We have hydrogen gas. Plus, okay, this is a gas, but I suggest let's not try to put gas. Let's ignore it because it does not affect the reaction. Plus oxygen gas will produce. Take note, it's hydrogen according to the wall of knowledge, diatomic element. Alright, very good. Yes. So we put 2 here, oxygen diatomic. Yes, Smith? Yes, diatomic, put 2 here. So is HO. In your table of elements, the HO, hydrogen and oxygen, oxidation number of hydrogen is +1, -2. What do we need to do? Say different. Yes, different. What do we need to do? If that's different, crisscross. So we got H2O. So that's basically dihydrogen monoxide. We need to balance the equation. We have predicted the right product. What about the the right balance equation. Let's count how many hydrogen atoms we have. Here, 2 oxygen, 2 product, 2, 1. There is something wrong. What is wrong? What is wrong? Okay, 2. So this is 2, this is 1. We need to put subscript or numerical coefficients. Okay, very good. Numerical coefficient 2 here. So we have cross over 2, basically 4, 2 times 1, basically 2. Is the oxygen balanced now? What about hydrogen? 4. What do we need to do? Very good. Put 2 here, so you will multiply. 4, 4, 2, 4, 2. Is the equation balanced now? Okay, that's correct. Thumbs up, thumbs down. Okay, thumbs up. What about example number 3? Let's talk about number 3. Aluminum plus sulfur. Let's try to have aluminum here. Aluminum. I'm going to write the equation. So we have aluminum plus sulfur will produce Al2S3. Take note. The products have been predicted. So let's try to balance equation. How many aluminum do we have here? 1. How many sulfur? 1. How many aluminum? 2. How many sulfur? That's basically 3. There's something wrong with aluminum and sulfur, correct? Alright, John, how would you be able to balance? This is 2. What do we need to do, John? Okay, put coefficient 2 here. It's not actually, it's numerical coefficient. So we have 2 times 1, 2. Is aluminum balanced now? Okay, check. What about sulfur? 3. What do we need to do? Alright, put 3 coefficients, so therefore it's 3. Is the equation balanced now? Very good. Thumbs up, thumbs down. Thumbs up. Now you're following. I want you to do number 4 and number 5. Okay. Take note for number 4 and number 5. We have to follow general rule. It means that writing chemical equations, balance the equation. Okay? Can you do it now for me? Alright, you got 2 minutes to do that. I'm going to move around, inspect your work. Okay? Alright. Now, what about number 6? Number 6, let's try to do number 6. There is a video about the experiment.
A combination reaction is when 2 reactants form one product. In this case, magnesium is reacting with oxygen to form magnesium oxide powder. The magnesium shown is a typical metal which is lustrous, ductile, and a good conductor of heat. Oxygen is the air we breathe. These are the 2 reactants for our chemical reaction. A spark or source of heat needs to be applied first so that the reaction can start. The bright light which is produced is the burning of magnesium, which reacts with the oxygen. The burning of magnesium produces the brightest light achievable by any chemical reaction. Do not look directly at this bright light when performing this experiment. The residue left behind is magnesium oxide powder, where magnesium atom bonds with oxygen atoms to form the product, which is a white powder.
Alright, this is question number 5. Now, let's try to talk about the experiment a while ago. What are the 2 substances have we combined? We have magnesium and oxygen, correct? And how are we going to predict the product? Yes, Paul? Okay, so this is basically combination of MgO only. Now, what do we need to do? Yes, Alicia, put diatomic element. That's very good. Then, what else? Are we going to balance the product? Okay, good. So for numbers 4, 5, and 6, I want you to do that, and I want you to turn that into me before you go. Okay? But in the meantime, while you are working there, in the meantime, let's try to conduct a simple experiment, a simple activity. Okay, a while ago you have just viewed one simple activity. Now let's try to apply combination reaction using laboratory experiment. This is a group work, you understand that? But basically, even though this is a group work, everybody is entitled to do their responsibility as a member. Now, in order to understand the group work, let's try to recall the 4 R's. What is the first R? rules and regulations. Everybody should be using or should be following rules and regulations. Number 2, what's the second R? Review safety rules. We have to do the goggles, we have to wear goggles, apron, gloves, okay? What else? Red, yellow, green. What's red? In conducting the experiment, you know what red is? Stop. It means something's wrong there, you're not following the procedures, you're not following the rules, okay? Okay. What about yellow? Yellow means warning. It means you have to think something is wrong, one is not following the rule, okay? And then after that, we have a green. Green means go, okay? So let's try to apply the red, yellow, green cards. And then the last one, we have what we call read carefully the instructions. I am here to supervise. I'm going to move around. If there's any question, you ask me. Remember, each table has a video from an iPad. So each station has an iPad. If there is something that you need to refer, there is a video from an iPad. It will guide you on the experiment for today. And take note, you have to respect each other, work independently, and always clean your station. I am also going to post a video here on the overhead just in case the iPad's too small for you. So I am going to play it over and over again. So this is station by station. So everybody should try to refer to your iPad or from the video in case you're lost while conducting the experiment. Okay? There is no sound on the video, so everybody stay focused on the station. Okay? Any questions so far? Suggestion? Okay, let's try. Thumbs up. Let's try. Okay, group 1, green card, go to your station now. Okay, settle down there. Group 2, let's go to your station. Group 3, let's go to your station, settle down there. Group 4 and group 5. Take note, you have only about 15 to 20 minutes to perform the experiment. Okay, and after the experiment, you need to clean the table. I am going to move around, supervise, and grade you according to how you perform the experiment. But of course, I am also going to ask you different questions based on the experiment. Okay? If there's anything that you need to start, to clarify right now, we can go ahead and start the experiment. If there's anything that you need to ask, any question you need to ask me, okay? I'm now going to move around to your station. Okay, 1 minute left. 1 minute. 1 minute. If there's anything that you need to talk about, interact with one another, this is the right time for you to do that. You got 1 minute left. It's almost 20 minutes. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, stop. Everybody should stop. Okay, now this is the time for us to work independently, individually. This is actually an individual assessment. All you need to do is just predict the product and balance the equation. You are going to write this in the handouts given to you in your respective station. At the back of your handout, you will see that there is a space there. All you need to do is just answer this, evaluate, predict the product, and balance the equation. Any questions so far? This is the right time for us to work independently, and this is my time also to figure out the result there, to know if you have cleaned the table and to prepare for the next class activity. If there's any question, I'm going to supervise each one of you. I'm going to move around. I'm going to stay at the back and stay in front also. Okay? If there's anything that you need to ask, okay, you may start working individually now. Go to your chair. Okay. Everybody met the standards. It's already clean. All stations are clean. You have 1 minute to answer. left to answer individual assessments. Everybody should be on page number 5. Okay, stop. I'll call group 1 to please place their handouts, their activity on the folder. Group 2, inside the folder please. Group 3, Group 4. Okay, Group 5, let's talk about your expectations. Let's try to recap. Have we met the expectation? What is the chemical equation and identify the reactants in the products? Okay, anybody can do that. It should be aligned with the standards. Okay, very good. What did I hear that from you? Tanisha. It composes of reactant and product. Okay, now what about how do we write chemical equation, proper chemical equation? There should be what? Oxidation numbers. Good. What else? Subscript. What else? Superscript. Okay, very good. And the most important, we have diatomic element. Okay, very good. Predict the correct chemical products given. How do we predict? Yes. Sam. Okay, there should be reactants, products, and a compound. Okay. Now, balance synthesis, the chemical reactions. Did we perform the experiment correctly based on the standards? Okay, so everybody is actually meeting the standards. Not meeting the standard is actually exceeding the standard. For your assignment, please answer page 200, numbers 1 through 10, World of Chemistry book. Or if you guys don't have any book, please go to my webpage, section 3. You're going to find those questions there. Okay? Now, is there anything that you need to ask? Any question? Thumbs up, thumbs down. Okay, the activity is very much interesting for today. Now, do not forget, it's almost time, do not forget, take it out of the door before you step out of the classroom. Please do not forget to write down something and then put it in the bucket. I'm going to answer them, all of them, tonight. So please, if there's anything that you need to clarify. Okay, it's time already. I'll see you tomorrow, I guess. Have a good day, everyone. Bye.